Welcome to Ask and Learn.
All right, so let's start with part A. So here we have our equation for the hydrolysis of ATP. This should be given to you in your book, and you should also be given the, oops, that's not what I wanted to do. Sorry. You should also be given, let's use blue. You should also be given the delta G. From there, in order to find K, we're going to use our equation. We'll be using this a lot today. Delta G equals negative RT ln K. So we should know that R is a constant. It is 8.314 joules per Kelvin mole. We know T is temperature. It's 298 Kelvin. And we know that our delta G is negative 30.5 kilojoules. Let me put Kelvin here. Kelvin, 30.5 kilojoules. And from there, we're just going to plug and chug. So I personally like to solve for K and then plug in all the numbers. So if you solve for K, you should get E raised to the delta G divided by negative RT equals K. And then you're just going to plug in the values from there. One quick note though, since our R value, R is in joules, we want to make sure our G is put into joules. So we're just going to multiply this by 1,000 in order to get it in joules instead of kilojoules, and that will be 30,500 joules. All right, from there, you're just going to plug and chug using this equation, and you should get K equaling 2.2 times 10 to the 5th. Okay, moving on to B. This is the dehydration condensation to form glucose phosphate. So I just put shortened, this is glucose, and this is glucose phosphate. Again, this reaction should be given to you in your textbook, and then you should also be given delta G right here. It's 13.8 kilojoules. We're going to do the exact same thing. So we're going to first change this into joules. So we're going to have 13,800 joules, and we're going to plug that in right here. So if you didn't want to rearrange the equation, you could also just plug it in like this and then solve for it. Oops, I left out an 8. Let's make that an 8. Equals negative 8.314. Remember, that's our constant. And then we have times 298 Kelvin. And then we're solving for ln K. So we would multiply these together and then divide 13,800 by that, and then take E to the power of that number in order to get K. So if you want to pause the video real quick and do that calculation, you should get a K of 3.8 times 10 to the negative 3. Perfect. All right, and then C, we have the coupled reaction between ATP and glucose. Again, you should be given this. You can also get it from just adding these two equations together, and the delta G again is negative 16.7. So the same exact thing that we've been doing. Let's change this into joules first. So we'll multiply by 1,000 and get 16,700 joules. And then you know what to do from here. So plug and chug. I'm not going to walk you through it, just give you a little bit of practice. Pause the video, go ahead and do that. And K should come out to be 8.5 times 10 to the second. Okay, and then D is probably the easiest question. It's just asking us how K changes when T changes from 25 to 37. So we know 25, let me write it, 25 degrees Celsius is 298, or 289 Kelvin, excuse me. And is that right? Let me think. So, yeah, 273. Yeah, excuse me, I am just having a brain fart today. Oops, that's not what I wanted. Eraser is 298. So forget that. We're gonna have 298 here. Whoop. And then 37 degrees Celsius is going to be 310 Kelvin. You can get those numbers by just adding 273. So to convert between Celsius and Kelvin, you just add 273 to the degrees Celsius. So in order to answer D, you're just going to change your temperature here. So instead of having that should be a 298 as well. Sorry, I'm having a bunch of brain farts apparently. Instead of being 298, you're going to put in 310 and then just recalculate. So again, you're just going to replug all the values you just did in, except this T is now going to be a 310. And from that, you should get at 310 Kelvin a K of 1.4 times 10 to the fifth. So as you can see, our K is decreasing. And we're going to do the exact same thing for the other two. So again, instead of this 298, we're going to put in 310 and redo our calculations. You want to pause the video and do that real quickly. At 310 Kelvin, the K is equal to 4.7 times 10 to the negative 3. So for the second reaction, K is increasing with increasing temperature. And for our last one, again, you're going to plug in 310 for our T value there. Pause the video and do that calculation, and at 310 Kelvin, you're going to get a K of 6.5 times 10 to the second.